shit.
That's what I'm talking about.
Wait.
Okay, now, from the beginning.
Hello. Hi, everyone. Good morning. Welcome to San Francisco. How's it going? Yeah? Welcome to Unity, and welcome to GDC. So today, we are going to talk about first look at Unity 2018, mobile AR key features. It's quite a mouthful. So I'd like to give it a subtitle. So basically what I'm saying here is all the stuff that we're going to show today is, it's the first time it's getting into 2018.1, so it's preview, so not necessarily fully fleshed out, but this is the direction we're heading in, and we hope that you guys come with us. My name is Jimmy Alamparambil. I've been at Unity for 1.5 years. I used to work in the Emerging Technologies team at Unity, but I found I was doing pretty much mostly AR stuff. So I recently joined the Unity XR team to help with all the AR stuff that we're doing. Previously, I worked at EA, Ubisoft, and other game industry companies. I used Unity professionally before joining Unity, so I kind of have I feel like I have a sense of what developers want out of Unity. So I try to do that in my day-to-day life, is try to enable developer success with whatever Unity does. My email address is shown over there, and I have a Twitter feed that is also shown over there. In my Twitter feed, I mostly tweet about AR experiences and things that people have done in AR that's kind of interesting and unusual, usually. And mostly things that people use Unity to do. I've also done a bunch of blog posts on stuff like AR-related stuff within Unity. And I'm also on the forums trying to support some of the AR initiatives within Unity. And I'd like to introduce my co-presenter, Tim Maurer. You want to say a few words?
Sure. Thanks, Jimmy. So I'm on the Unity XR team, and I've been working with Jimmy on some of this stuff. So a lot of what I do is I integrate new hardware, new AR devices. I've been working a lot with ARCore and ARKit recently, and I've been developing some of the AR APIs that we're going to be showing you today.
Thank you, Tim. So this is the agenda for the talk today. We are first going to look at the current state of affairs, what Unity does today for supporting mobile AR, how you can use mobile AR today with Unity. And then we're kind of going to look a bit forward. What does 2018.1 look like? What are the things that we have in 2018.1? What is the new architecture we're looking at for this year for mobile AR, and how we want to go forward? That would include basically firing up the editor, have a look at what 2018.1 looks like with mobile AR in the editor, as well as some demos on devices. And then after that, we'll look a bit beyond 2018.1 and what we want to plan for the rest of this year, coming year at least. And then hopefully we'll have a little bit of time at the end to take some of your questions. So what is the current state of AR? So current state kind of looks something like this. We have developers who can access the plugins that support AR SDKs, either through GitHub or Bitbucket. And we also created a multi-platform layer that can interface with both systems. This experimental AR interface, like we call it, was made for a Unite talk last year. And it does a job of writing the code once and targeting both of the existing mobile AR SDKs. So this is how people have currently been using Unity with mobile AR. Just as a matter of interest, how many of you have used this setup or some semblance of it? Excellent. Yeah, about 25%, I guess. So I can show you some, right now I'm going to go through some examples of people who have used this and what they've done with it. Do you have the volume, sir? Mr. Audio person? Let me start it again. All right, so this is basically an app that uses the perspective of the device, essentially to solve puzzles. So it's kind of like a interesting, unique way of using AR. This is just using Unity physics to basically implement basketball physics. This is a toy train on a table, or a railway track on a table, I guess. So one of the things that people like to do is placing furniture. This is kind of like a non-gaming kind of app. Place furniture in your room and see how it looks like, and measure your room and do some home improvement sort of things, like check the paint. That's some new uses of AR that people have been experimenting with. This is just a mystery game. And this is another favorite thing that people like to do: configure cars, supercars, and place them in different locations, play around with them, do some test drives, etc. This is a computer vision app which basically takes a drawn butterfly and makes it come alive in your world. This is Lego, and half the things here are real and half of them are virtual. And the virtual things project shadows on the real things. This is Corey. He's done some motion capture. Interesting part here is he uses an iPhone 10 to capture his facial animation. This is Matthew, who's got a project. This is an open source project, actually, where he reimagines Portal using this AR, mobile AR. It's actually based on a HoloLens project that was similar. And this is just a kids app that uses AR, educational app. This is Audi's AR app, which you can actually download from the App Store. It basically uses very similar assets that they had in their ad. They had an AR ad for that. And this is Abhishek using Street Fighter assets to bring Street Fighter to the street. So these are just some of the interesting applications that are out there. Obviously, I wouldn't be able to cover all of them, but it kind of gives you a taste of what. I mean, there's also all kinds of different experiments out there and ways of using AR that I haven't really shown here. But again, there's things out there that you can use, and actually open source projects that you can try out yourself. Just curious again, how many of you have AR apps published? Again, about a quarter. How many are hoping to get one published this year? All right, awesome. So what we have currently is this. So what are some of the benefits of this? So since these are all open source components, it's very easy to update them as soon as AR SDKs update or new releases of AR SDK come out. You can update them very quickly. Any bugs and other feature requests that come through, you can quickly update any of these components and get those in there. We get a lot of community feedback on features people want, or bug fixes, or things that people want to implement, and we can quickly react to that. And the other thing, as you might know from our Unite talk last year, we solve a lot of common problems that people have. We provide higher level components and scripts to solve things like setting up a session, camera, et cetera. So these are some of the things that already work with AR interface, and it's benefits. But there are also drawbacks to AR interface. And kind of the things that we want to deal with is the integration with Unity is kind of not very tight. It's kind of loose. So we have not much, we wouldn't be able to use native code very easily with the loose integration we have with Unity. So, and also, we have to implement some of the editor stuff externally, not within the Unity engine itself. There's system fragmentation as well, because people may use the AR interface, or they may use the SDKs directly. And so, and also some people may use different versions of these plugins and SDKs to do AR. So there's a lot of contention or fragmentation of these APIs. The AR interface itself was put together pretty quickly. I think it was in a week or so, just before the Unite talk. So it's probably not been vetted quite a bit. And also, all these things are in separate, unrelated repositories. So we have basically a repository for each of these components, and some of them are not synced up properly. So when we update one of the SDKs, we have to make sure that the AR interface can support it before we actually copy it over, that kind of stuff. Because of this, there's also higher maintenance cost. We don't have enough resources to kind of maintain all these different disparate solutions, and that's another problem with it. And we haven't had enough resources available to implement new functionality that AR interface could support. So how do we see us being able to kind of have the same benefits that AR interface has, and yet not have the drawbacks? So this is what we kind of look at. The main thing we want to solve is the fragmentation through native subsystems. So we solve them by using native subsystems that interface with the AR providers. What that allows you to do is the native subsystems provide an API that's standard that any one of the other providers can actually implement, so that as a developer, you basically just have to work with one API, and you can support all these other third-party providers. And you don't have to access third-party APIs directly. So under that architecture, this is what we have in 2018.1. So some of the advantages of doing this is whenever the AR SDK releases happen, we can quickly implement those AR SDKs within the provider. So the provider is the only thing that changes. So provider changing the data is the only thing that changes, and it provides the data to the AR subsystems outside of. It doesn't have to be on a Unity release. It can be outside of the Unity release. We also can do the quick updates and bug fixes, as well as the community feedback kind of features, all within the providers, without having to rely on a next version of Unity to do that. It also solves common problems, and the way it does that is we have a layer called AR Utilities, which uses the AR subsystems to offer a kind of like higher level API for each subsystem, and some utilities that help along with. So we don't think people will be using the AR subsystems directly, but more at the utilities level, because for the most part, you probably are going to be using some common functionality that AR will give. So, and some other advantages which kind of compares to the drawbacks that you have with AR interface. This application, this architecture has tighter integration with Unity. So the AR subsystems are partly written in native code. So they have this tight integration with Unity, and we can basically hook into the lower levels of Unity engine to be able to do more performant as well as more integrated interactions in the editor, et cetera. And you can reuse some of the systems that Unity already provides for some of the AR stuff that we need to do. We still have the high-level API for subsystems. So again, we have separated out the providers from the Unity engine development, so you can develop at a separate pace. Again, we have seamless integration for other providers. So in case new hardware comes out or new AR data providers come out, they can just plug into our subsystems, and they don't have to basically be relying on any Unity engine changes to do that. Some of these pieces will be open source. The AR utilities, for example, will be open source. And the reason for that is we expect, again, community feedback and things that the community might do where they might create new utilities or new functionality that can feed back into this AR utilities. The native subsystems, again, this whole architecture is fully supported and maintained by the XR team, which is a pretty important team within Unity now that we're focusing on XR for the next year. So we are going to have, this is a very important distinction from what AR interface had going for it. Essentially, we only had a couple of people, maybe 3 or 4 people working on the AR interface stuff, but we're going to have a full team that maintains and supports and makes these interfaces progress in the future. A kind of quick dive into subsystems. What are subsystems? In AR, we have various sorts of data that need to be conveyed from the hardware or the SDK up to the application level. And a subsystem is just a piece of software that conveys this data in a granular way. So it basically focuses on one sort of data. So an example is if you have a plane subsystem, it only worries about planes. So it gets the SDK or the hardware to provide plane data up to the application. There's glue code, obviously, that allows the plane provider to provide this data. Similarly, you'll have all these different subsystems that are sort of like silos, which provide different kinds of data which applications need. And we've separated them out in these silos just because we see that we might need to be able to mix and match these different providers of data. So you could have all the data for like planes, camera, and input being provided by one piece of hardware, or you could have multiple SDKs providing this separate data, or you could even have a software simulation of one of these providers. So for example, you could have a fake input if you wanted to test out your input code, and the fake input would provide this input subsystem data, which you can reuse in different ways. So we see this mixing and matching of these subsystems to create an AR app. These are some examples of subsystems that we currently have in 2018.1. They're pretty low level. They're meant to be combined together in different ways to allow you to create AR apps. But since they're so low level, we expect most people not to use them directly, but need some common higher level tools to use them. And that's where AR utilities come in. The AR utilities are more of these higher level components, commonly used utilities for AR, wizards, et cetera. And we're going to see some of them as Tim demonstrates what we have in 2018.1. And so without further ado, Tim, you want to have a look at 2018.1? How do we do this?
Cool. So what I'm showing you here is a version of the editor. It's 2018.1 beta 12. Let's just hand these off to Jimmy. So I want to kind of walk you through what it would take to set up a really basic AR scene, and then we're going to kind of build on that. So like Jimmy was saying, in 2018.1, unlike previous versions, now we have a new C# API specifically for talking to what we're calling it XR, which encompasses VR and AR, but we have a lot of subsystems around AR in particular. So rather than having to go to, say, GitHub or Bitbucket and download different plugins, now they're all kind of built in with the editor. And then another advantage is one of the things that we're launching in 2018.1 is something called the Package Manager, which allows you to download sort of piecemeal functionality into Unity. And so you can see that I've already got a package for the AR Core plugin and also AR Utilities. I'm going to talk more about that in a minute. And then this allows us to kind of update these packages out of band from the normal Unity release cycle. So if AR Core comes out with version 1.1, we can just rev the package, and there'll be a button here that says update to the latest. So that's how you'll be able to interact with these things. And then we can add more support for other hardware or other devices in the future. So right now we have AR Core and AR Kit, and then we'll be transitioning to provide support for things like HoloLens. And this morning, in case you missed it, we just announced a partnership with Magic Leap, so that'll be coming through in the future as well. So I'm going to just kind of walk you through what it's going to take to set up a really, really simple AR setup. So this is like the simplest scene you could possibly imagine in Unity. We've got a cube at the origin, and we've got a camera at the default new scene position of 0, 1, -10. And then the only thing that I've done here is I've added a component that simulates user input. So I've called it the simulated TPD. TPD stands for Tracked Pose Driver. I'm going to explain what that is in just a minute. But basically, this is going to act like a user holding a device and moving it around, and we're sampling that position and orientation, and then we're applying that to the camera. So I'll go ahead and hit play so you can see what that looks like. And so on the left side, I've got the scene view, so you can kind of see what's going on. On the right side is what you would actually see on the device in the game view. And you can see that right away we've snapped to the origin, 0, 0, 0. You can see that we're still moving around, we're sampling the motion, but we don't see anything in the game view, and the reason is because our camera is actually embedded inside of the cube. The reason that that happens is because the device, when it starts up, it doesn't know where it is, it has to work that out. And all the position and orientation information it reports is relative to that initial starting position. So AR Core and AR Kit both call that a session. So when you initialize an AR session, that becomes your origin. So everything that the device reports after that, including all the, if it reports plane data or meshing data or feature points, all of that is reported in what we call session space relative to that initial origin position. So we want to actually be able to place our camera in an arbitrary position within Unity. So we can do that pretty easily by just adding a parent game object. So I'll parent the camera to that. And I'm going to call this AR rig. And so now my AR rig has position 0, 1, -10. And my camera, its local position is 0, 0, 0. And so now when I hit play, everything kind of makes sense. So it stays more or less where we put it. We still get the relative positional and rotational offsets. And I can kind of move my rig around and reposition it as I want to, whatever makes sense for the scene. Now, so that's pretty nice for positioning it, but we get something else almost for free. So I've got a component that all it does is sets the scale of the transform of this game object, but it sets it uniformly. So I'm going to just kind of manipulate the scale value here. So this is what I'm doing is I'm scaling the rig, and then the camera is a child of that. So when I scale that up, essentially what it does is it magnifies the movement of the camera. So right now, so let me just set it to 10, so we have a nice round number. So this is like when I take one step forward, it's like taking 10 steps forward. If I take a step back, it's like taking 10 steps back. And the effect is that it's going to look like the content is either bigger or smaller depending on how we manipulate this scale value. So that's going to come in handy in just a minute. Now this would also apply to any other detected data from the device. So say we want to visualize feature points or we want to visualize planes. Those planes can also be children of the rig. And that means basically this is your session space down here. So anything that is a child of the rig is in session space, and then that rig sort of translates it into Unity world space. OK, so let me show you a really basic scene. So this is connected. Oh yeah, we got to flip back. Yeah, okay. Can you do just the left one? So some of these visualizations that you see is also part of some material that we're going to be providing with a template. So when you start a new scene, you'll be able to say, I want a new AR template, and you'll be able to use some of these assets in your own project. So what I've got is I'm drawing a plane that was just detected on the ground here. You're also seeing little sort of crosses, the yellow dots. Those are the feature points. So I can turn those on and off. Let's turn off the feature points for now. And then I can also do a raycast from any arbitrary position and raycast against planes and feature points. And so what I'm doing here is just tapping on the screen, doing a raycast, and it's an AR raycast, it's not a physics raycast. So this plane actually has no physical representation. It could if we wanted to, but it doesn't here. So we can raycast just against the planes, and then I'm obviously placing a cube at that location. Okay, so that's kind of just the hello world of AR, just a really, really basic example. I want to move on to something a little bit more interesting. So I'll go back to the editor here. Let's save that. All right, so let's do something a little bit more complex. So I've got a scene here. Don't need to be drawing all that. Okay, so I've got a scene here that uses Unity terrain, and we've got some interesting lights. We've got a little castle asset, and I'm going to go ahead and hit play again. On the left, we've got the scene view. On the right, the game view. And I've added some physics, so it's just going to rain giant spheres on the castle. So this is just to demonstrate that we've got some interesting dynamics going on. And I'm going to zoom in on the castle for a second to show you these particle effects. So we've got some sort of flame particle effects with some smoke. Now, this uses the Unity terrain system, and if you've used that before, you might recall that once you've placed it in the world, it's basically static. So you actually see the word static here showing up by the manipulator widgets. So I can't move it, I can't rotate it, I can't scale it at runtime. So that's going to be a problem for us if we want to be able to place content, say, something like this. This castle was authored at, I think it's 20 meters tall. So if I place that in my world, say on this tabletop, I don't want it to actually be 20 meters tall, right? I want it to shrink down. So how can we do that? Well, the obvious thing is simply just to apply a scale factor to the castle. So say I want to just scale this asset. So let's say 0.1, 0.1, 0.1. Actually 0.1. Okay. Okay, so this seems to have scaled everything for us. You can see the colliders are smaller, the mesh is smaller, but there's a problem. So you'll see it in a second. So it didn't quite scale the particle effects the way that we thought. Now, it is possible to scale down the particles to get them to look right, but it generally involves going into the particle system editor and tweaking a bunch of variables to get it kind of just what you want. So that's not really the kind of thing that you want to be doing if, say, you're grabbing some assets off the asset store that were modeled in meter space, and you want to create a curated AR experience. You're going to have to go and tweak a bunch of stuff. And sometimes you don't know exactly what scale you want to put it on. So I might wait until I detect a particular surface, see what size it is, and then try to scale my content to fit that particular size. So that's going to be very difficult to do dynamically if you're trying to scale the content. And then not to mention, physics interactions are going to change. So the physics system can handle objects at different scale, but it's just an approximation of real-world physics, which means the exact behavior that you get is going to change. And so if you have gameplay that relies on specific interactions of physics, it's going to change as you undergo scale. So you typically don't really want to apply scale there either. All right, let me get my castle back to the original values here. And then, of course, there's the problem with the terrain. We can't apply any positional or rotational or scaling factor to that at all. That's not going to work. The same is actually true of nav meshes as well. So there's a couple systems in Unity where you just don't really want to, well, you can't scale it, or even if you could, you probably didn't want to. So how can we get around that? So I've got a rig, an AR rig in this setup. And I've got kind of a fake plane over here. So this is just an editor-only plane that I've created so that I can demo it in the editor. And you can see that we've got our rig is way back here. And our content that we want to place is in front of it. So we see that over here in the game view. We've got our content and then the plane. And what I want to do is make it look like I'm putting that content on the plane. But I can't actually move the content. So what I'm going to do is instead move the rig in such a way that the plane kind of ends up underneath it in the right spot. So I've slowed this down. Normally you would do this all in one go, but I'm going to slow it down in the editor so you can see it. So keep your eye on the left side of the screen. So I'm going to click on the plane, and then we move the rig so that the content appears where we clicked. We do that one more time and kind of zoom out a little bit. Okay, so we don't move the content. We move the whole rig back, and that has the impression that now the content is where I placed it. All right, so let me zoom in on this plane. And so I can move this around. Notice the content's not moving at all. It's just the rig and the planes and everything. Now, the plane didn't seem to change size or move around at all in the game view, and that's because it's part of the rig. I'm only moving the rig, so the camera and the plane maintain the same relative position to each other. They're not moving at all. And we can even apply scale. So if I scale up the rig, it ends up scaling the planes and scaling the position of the camera. But of course, the content's not changing, but on the right, it looks like the content is getting bigger and smaller. And we can do the same thing with rotation. So when I rotate the rig, see, it's really just orbiting the content, but the result, or the sort of apparent result in the game view is that we're rotating the content. Okay, so I'm going to show that on a different device this time. Sorry, before I should have said that was a Pixel. So that was using ARCore for the first demo. I'm going to use ARKit on the second one. Are we connected? Do you need me to connect again?
Yeah.
Okay. Yep, there it is. Cool. All right, so let's find a plane on this wooden feature here. Okay, there we go. So I've placed my content, and now I've got a couple sliders here where I can scale it up and down. I can rotate it. I'm going to turn off the visualizers here so we can just focus on the content. So let's make it so it kind of appears that it's the right scale. Position it here, rotate it. And you can see that all the physics is completely unaffected because we're not actually scaling anything here. We're just moving our position around it. And then the particle effects still look good. So everything looks exactly like we would expect how we authored it in the editor, but I can kind of scale it up and down and position it however I want at runtime. Okay. So that's that. Are we back here? Okay. So that's kind of how we're recommending people build AR applications. And this is part of the AR utilities package that I mentioned earlier. So you'll be able to work with that rather than working with the sort of the raw C# API. That's meant to be very close to the metal. We want to provide these kind of higher level utilities. So one thing that I haven't showed yet is, let's say that I was starting with a new scene. Everything that I've showed you, it's a lot of clicks to remember. You've got to kind of remember exactly how to do this setup. So we've got a couple of wizards in here. So I right-click in my hierarchy view, AR, create a rig. And now I just have these simple options that I can fill out. So this also tells me, it also controls the session itself. So some of these features like plane detection require extra processing power, which is going to use extra battery. So you can turn those on and off if you're not actually using them. So let's say I want plane detection depth data. That's things like feature points, point cloud. The video overlay is the pass-through video, so that it actually renders the image of the color camera on the screen. And light estimation, so both ARCore and ARKit can estimate the amount of ambient light, and you can use that information in your scene. And then we're going to create a rig with a particular scale and a culling mask, and I'm going to come back to that in just a second. So if I just click create, then it creates a session. There's only ever one session in the scene because that's sort of a global singleton. Controls the life cycle of your AR session, so you can only have one at a time. But these are all dynamic runtime options, so you can at runtime toggle plane detection on and off. And then it created the rig with a camera using the track pose driver. So I mentioned the track pose driver earlier. This is what actually samples pose information, that's rotation and positional information from the device, and then applies it to the camera. So we're sampling from a device, the color camera, and position and rotation. So that's what's going to actually drive the camera. So this wizard kind of sets all that up for you. So a couple clicks and you're ready to go. Now, I mentioned that there can only be one AR session, which is true, of course, but there's no reason we can't have multiple rigs. So you actually see one of the wizard options here is to create a multi-scale AR. So this one's going to create as many AR rigs as I want. Just expand this. And now this is where our layer mask is going to come in handy. So you notice there was that one parameter, the culling mask. So you can tell a Unity camera to only render particular layers in the scene. So we can say, I want, these I have a couple of custom ones, content 1, content 2, debug planes. So this setup uses multiple AR rigs with multiple cameras, and each camera is only rendering a subset of the scene. So let me rotate this around and zoom out a little so you can see what I'm talking about. So here I've got two villages. So that's village 1 and village 2. And just for a sense of scale, in village 1 here, oh, it's big. This is the castle that I was showing you earlier. So it's actually just a small part of this larger scene. And then village 2 is the same asset from the last demo. So let's say that I'm making like an RTS game, and I want to set one village on one surface and another village on another surface, and I want to be able to scale and rotate them independently. I don't know where those surfaces are going to be relative to each other, and I can't move either one of these contents at runtime. So what I'm going to do instead is have a couple of rigs. AR rig number 1 is responsible for only rendering a couple of debug things, and then content 1. And then you can see that village 1 is in a layer called content 1. What that means is that that camera is only going to render this village. So it's just going to ignore the rest of it. And then the same thing for rig 2, it only renders village 2. So these starting positions of the rig are just kind of arbitrary. So you can see I've got rig number 1 just kind of floating over here, and we're drawing one debug plane in the game view. And then AR rig number 2 is somewhere over here, and it's got another plane over here. So I'm going to hit play in the editor. It'll be just like the previous example. So one piece of content goes here, the other piece of content goes here, and then I can scale and rotate them completely independently of each other. Okay. So it looks like they're in completely arbitrary places at different scales, but of course we're just using a few camera tricks to get around that. All right. So I'm going to show that on the phone, on the Pixel this time. Okay. Good. All right. And in case you're wondering, the reason I've put these things down on the floor is to give the floor a bit of extra texture that tends to help with the feature detection. All right, so I've got one plane there. I'm going to try to use the wood block to get another one at a different height. Okay. So I'm going to place the first piece of content there. And I like this one. It's pretty complicated. We've got things like some particle effects at these enemy gates. There's my castle over there. Some volcanoes. Let's rotate and position it so it fits on the plane, or fits on the surface here. And then I'm going to put a different piece of content on the ground. And I think I can turn off my plane visualizer now. And then we can rotate and scale that one independently as well. There we go. All right. that's that. OK, let's switch back to, no, wait. No, we want to stay on your computer. All right, so that's it for live demos. Didn't have to sacrifice a chicken this time. All right, so just a quick summary of what we showed. All right, so we're going to have wizards and templates that help you set up AR. I didn't talk too much about the templates, mostly showed the wizard. In the future, probably in the next version of Unity, you'll be able to say, I want a new scene. And instead of just an empty scene, it would be what kind of scene, a VR scene, an AR scene. And some of the assets that you saw, things like the plane visualization and the focus square that said, you should move your phone to do some tracking. Oh, there's a low light warning. All of those assets will be available for you in part of a template. And then, of course, you'll have the wizards that kind of help you set up your scene in a couple clicks. We talked about the AR rig, so that's kind of the recommended way of creating an AR scene and controlling the position of the camera as well as scale. Speaking of scale, as we said, the TLDR is that you scale the camera, don't scale the content, unless it's really simple content like a cube or something. But most of the time, you want to actually just scale the camera. And then finally, we showed you multiple surfaces with multiple scales. So there's no limit to that. You can have as many AR rigs as you want. OK?
Thank you, Timmy. So now we want to look a bit beyond 2018.1. For the rest of 2018, what are we going to do with this kind of new architecture? Mainly, it's along the same lines. We want to get more higher-level components into your hands so that people can implement all kinds of experiences. So we probably want some feedback on what kind of experiences that you guys want to create so that we can create all these higher-level components. We already have some in mind. We also want to create more developer-friendly authoring solutions. What that means is we want you guys to be able to iterate really fast on your experiences, so you don't have to build out to the device every time you want to try something out. So that might mean some remoting capabilities, or it might mean some simulations or recording and playback, that kind of stuff. But also, the other thing that we want looking forward to is mobile AR is still developing at a really fast pace, and there's new things coming out all the time and new systems that we need to support. So we're looking at more subsystems that we need to kind of develop that's going to support all these different kinds of data that are now coming through. So those are the kind of things that we're going to look forward to as we go along. And as I mentioned before, we have the full support of the XR team. And that's a pretty big team within Unity. Some of them also helped out in this presentation. So these are kind of like a mugshots of some of the people that helped out with this, as well as they'll keep on helping out with more of the development of this new architecture and mobile AR in the future. And that's all I have for today.
So we finished a bit early. I think we've got time for some questions. Yeah.
Repeat the question.
So in your example with the scene with the two villages that were positioned in different areas in the space, because you're scaling and transforming the cameras as opposed to the actual objects, you kind of lose the ability to have them interact in the world, right? I mean, how would you recommend doing that if you wanted to have the two different cameras and worlds like throw objects at each other or something?
Yeah, I'm smiling at a coworker because we were just having this conversation the other day. Yeah, so that's kind of a trickier problem. And what you'd probably want to do, I think the solution, we don't have a good demo showing this yet. I'd like to put something together to kind of try to express that. So imagine that we wanted to build a bridge between these two objects, but that bridge might be, we're going to attach it at random points, and it's going to be at different scales between the two objects, right? And then you want to have a character walk from one bridge to the other. So what you do is you'd have a third asset here and maybe it's your bridge component or your bridge asset, and it's just a straight line. And then what you do is have a third rig to draw the bridge, and you would, as say the character moved from one part of the village, from village 1 to village 2, you could start pulling back the rig and adjusting the scale dynamically so that he arrives at the other village with that scale. That's not yet been proven out. It's definitely a little bit trickier, and especially when you start thinking about, well, now I want a tower on this village to shoot at the character as he walks across. You'd have to do a little bit of trickery to kind of, teleport the projectile or whatever from one space to the other. But we do think it's possible, so I'm hoping to put together a more elaborate scene kind of attacking that use case in the future.
Thanks.
Yeah.
What about sound and interactions?
Sound and
And adding are you able to add 3D spatial sounds? And also, what about other animations and interactivity?
Right. So for 3D sound, you'd probably. That's a great question. So just in case the question was, how do we handle 3D sound and other animations? So for 3D sound, you could do something similar where you've got a listener on each rig, perhaps, and then you'd want to do some mixing between those. Again, this isn't something that we've, there's obviously a lot more that we could do here in terms of demos and trying to attack all of those different use cases. But I imagine that you ought to be able to do something similar. One of the nice things about the rig is that you can sort of choose to either work in session space or Unity space. So for something like sound, you probably want to use the actual physical distance that the user is rather than its perceived distance in the Unity space. And you can get that information by using sort of the local space of the objects. So that's kind of what you'd want to feed into your sound mixer.
There is also something similar that we were talking about earlier is if you wanted some kind of interaction with the scene, let's say a character wants to go to a certain point in the scene, you'd use the local space of the scene because the scene is actually miles long rather than centimeters. So you'd use the space of, and that's already exposed in the transform that you get. So when you do a raycast, you can get the local space, or you can get this. Yeah.
I'm sorry, what was the question about animations?
I'll be a little more specific. AR enables us to be able to interact differently. Well, same in VR, but distance, for instance, like can you have triggers on how close your phone is to an object and other types of interactions?
I see. So something like a trigger volume, but in AR. That is a great question. That's not something that we've implemented yet.
It'd be really cool.
Yeah. I'll definitely take that back, and maybe that'll become part of the AR utilities someday.
I mean, you could basically do it similarly to the layers for rendering. You could just have a layer for the collision for that particular trigger, for example.
I mean, yeah, I guess you could use the existing trigger volume system, and if it was parented to the rig, it would also undergo scale, so that everything would be self-consistent. Let's get a question in the back, in the red hat.
If I'm doing an intermediate step with ARKit, I have Xcode in the middle, right? AR remote, to my knowledge at this point, like I've had trouble with touch simulations, et cetera. So is there any, first of all, device to make it quick in terms of, like, for example, can I preview this scene and actually debug on the device and run in the editor at the same time?
Right, so the question, I think, is basically around things like remoting and simulation. So quick iteration time. We don't have that yet in what I'm showing you today, but that is going to be coming later on this year. So we want to have support for remoting, which is basically using your, so there's already a thing called the Unity remote where it sort of sends touch input and stuff back to the editor. We want to flesh that out and actually include, basically support the AR SDKs using something similar. So you'll be able to use your device as just a remote touch input, but you can still develop inside of the editor. And then the other part to that is simulating, so being able to develop an entire experience completely inside of the editor, and then when you deploy to the phone, hopefully it tends to work in the same way. And I guess the third component to that is being able to record a previous session. So one of the annoying things about like actually testing is you typically need to find a plane before you can do anything. So you end up deploying to the device, waving your phone around until you find a plane. But if there's a way that you could sort of record a previous session, or even maybe have a curated set that's provided by somebody that you can like download a coffee shop #1 or something, and you can load that up in the editor, and then you can sort of pretend to, you can simulate that experience inside of the editor. So those are all kind of on the drawing board for later this year.
Awesome. And are there plans, like I noticed you have some of the debugging stuff with the side menu, releasing that so that I don't have to reinvent that as well? Is that possibly part of the plan?
I'm sorry.
Some of the debugging tools that you guys have already,
Yep.
is that part of the plan to release that well? That'd be awesome if you could.
Yeah, I mean, those are, the way that works right now is that I just created a regular Unity plane that is parented to the rig. What we'd like to do is have more of I think that the right way to do that is to have a provider, which is what we call things like ARCore and ARKit, have a provider that runs on the desktop, and then have a C# API that you can say, I want to instantiate a plane at this point, and then everything just works exactly like as if it was on the device. So you'd still be talking to an AR SDK, but it's sort of a mock AR SDK that's...
Was your question about the sidebar thing that came out? Yeah, okay. So yeah, we are going to include that.
Oh, I'm sorry, Dan.
We're going to be including that as part of the AR utility.
Yes, that will absolutely be part of the package. Yeah.
Awesome. And sorry, last one. One of the things you pointed out that it updates fairly frequently. One of the things I've enjoyed about the GitHub, I'm sorry, not the plugin that you've just joined in GitHub is like you guys refresh it fairly quickly. For example, there's support for vertical planes, things like that. When you have this added abstraction layer, how would we, for example, if it's 11.4.beta, whatever else, how would we incorporate this, or will this always track with an official released version of ARKit or ARCore? Does that make sense?
Yeah, so it's a good question. Yeah, it depends on how big of a feature change it is. So for example, we already support vertical and horizontal planes in the AR SDK. So if in the future, ARCore, right now it's just horizontal planes, but in the future when they have vertical planes, we'll just be able to rev the package and that'll just work. So we'll be able to do that fairly quickly. It's one of the advantages of using the package manager is that we can update that pretty much at any time. Now if they add like a big new feature like, I don't know, support for full mesh reconstruction or something, that's going to probably have to wait until the next Unity release so that we can incorporate that at a deeper level. But yeah, so it kind of just depends, but we will be able to update the packages. Certainly if we find a bug or something, we can just update that very quickly.
And I think part of the plan is also to try and make this more, like the subsystems themselves more iterable, or like being able to be updated much faster than the Unity cycle. We haven't quite figured out exactly how that's going to work, but I think that's the intention, so that we can create, we can basically allow people or support any new features that are coming out without having to wait for a new Unity release. So that's one of the aims that we want to head towards.
And I guess another point on that is some of the stuff that we're showing, like the AR utilities, that's just a C# package. And so right now it's just it's kind of a black box. I mean, you can see the source there, but one day that'll be opened up more, like maybe it'll be on GitHub or something, and people will be able to make pull requests. So we kind of hope to make that more open source. I shouldn't say open source, but open to sort of public consumption. You had a question?
Yeah, sorry, some of our dependencies are to grab the camera frame, like an unaugmented camera frame, like you mentioned video pass-through earlier, and also have control of focus and exposure on the cameras on from the device. Are you intending to support that, or do you already support it? Or?
So the question is about exposing aspects of the camera frame. Are you talking about the ARKit AR frame?
Yeah, so like literally the video of the scene.
Yeah, so the way it's done right now is it's done on the native side, so it writes to like textures and writes data directly to the camera. But you should be able to get access to all of that information. You should be able to just get the texture as a regular Unity texture that represents the background image of the camera.
So we can already do that.
Yeah, you can already do that. Sorry, there was another part to your question?
Yeah, the other one was like controlling focus and possibly exposure of the camera as well.
Right, so I know ARKit added that in 1.5. We just haven't exposed that in our multi-platform C# API, but we'll be adding things like that in the future, for sure.
Do you know in ARKit if there's I don't know, in iOS you can set the exposure and focus separately from the app, right? But
Okay.
that's then ARKit at the moment overrides that, but I think they're intending to change it. Do you have any idea of support for that?
So ARKit does not support, so all it supports currently in 1.5 is the ability to do autofocus instead of infinite focus. So those are your two choices. You enable autofocus or you use infinite focus.
Yeah, we found that if we set like exposure values and then their autofocus control actually overwrites that as well, sort of randomly.
Well, I wasn't aware of that, but yeah, it's something that, again, that's very specific to specifically AR SDK. We're looking at the big picture right now.
Okay, maybe one more. Yeah. Yeah. So right now it's just kind of a single plane detection, and it's both or nothing. I think maybe what you're asking about is how do you determine if the platform itself supports those sort of micro features? So we do have a system, so every subsystem, like plane subsystem, has a set of feature descriptors. So you can kind of query for, I don't think we're that granular yet. I think it's more like, is plane detection supported or not? So right now we don't have a good way of exposing that particular sort of nuanced difference between vertical and horizontal planes. So you'll just get them or you won't get them. One thing that's nice, like a couple of things with raycasting, you always get a pose back, full rotation and position. And so one of the big features of ARCore 1.0 is that they have oriented feature points, which means when you do a raycast and you hit a feature point, it'll not only give you that position, but an actual orientation. And so we just support that kind of naturally because our raycasts always give you back some kind of pose information. And all we would have to do then is, because it's already supported at the C# API level, all we have to do is rev the package to provide that data correctly. All right, maybe one more question?
Actually, I think we're
Or are we
out of
over
time,
time? Oh,
but
okay.
thank you everyone for coming
All right.
in.